All right, guys, let me walk you through how to sequence a number of lights turning on. So we have two lights here. And the sequence here is that, let me show you what I'm asking. You see this in your textbook, but let me just bring this up. So we're doing, the first step is that light 1 is going to turn on and it's going to stay on. Second step is that light 1 is going to obviously be still on, and the second light is going to turn on and stay on. Then the third step is that the first light is going to turn off and the second light is going to remain on. Fourth step is that both lights will be off, right? Light 1 is off already and then light 2 will be off. Step 5 is that we're going to return right back to step number 1 and light 1 is going to turn on. The way that we sequence between all of these steps is by pressing a push button. So we're going to have a push button with a positive pulse that comes through. And every time that we hit the push button, then we move on to the next step. So first step here would be push button is pressed and no steps confirmed yet. Or that we have reached step 5 and we're reverting back to step 1. But initially we're pressing the push button and no steps have yet been confirmed. And then light 1 turns on and stays on. That step is going to end when step 2 becomes active. So once step 2 becomes active, step 1 is no longer active. So when step 2 is ready to go, we hit the push button once again. Positive pulse comes through. Step 1 is completed already, and the light turns on. Okay, so that would be light 2 turning on, and it's staying on. Okay, step 3, the push button is pressed. Positive pulse comes through. Step 2 has already been completed, and in that case, the light 1 turns off. Light 2 is still on. Next one, positive pulse. So you can see how this keeps doing the same thing. Positive pulse, previous step has been completed, and the next light turns off. So light 1 on, light 2 on, light 1 off, light 2 off, and then return to step number 1. Okay, so we're going to show you the program in 2 seconds, but let's walk through the sequence here. So I've got my step 1, step 2, step 3, step 4, and so each of those guys are either turning on the lights or turning them off. And so here we'll see when I hit the push button for the first time that step 1 should become true. So I'm pressing that now. Okay, so step 1 is true and it's now set the first light. So light 1 is on. Okay, pressing the push button again. Step 2 should come in. Okay, so we're now in step 2. Okay, so that's true. Both lights are now on. Step 3, the first light should go off. So pressing the push button now. Sometimes there's a little bit of delay there. So step 3 is now true. Light 1 is off. Light 2 is still on. Pressing the push button once again. The second light should turn off. Okay, so now we're in step 4. Both lights are off. When I press the push button once again, then we should go to step 5. And step 5 will bring us back to step 1. And the first light will turn on. Beautiful. Okay, light 1 is on, and now we're back to step 1. Okay, let me walk you through the program below here. So we're going to build it up together. I'm going to show you everything working first, and then we'll build it up together. Okay, guys, so down here we can see that we're in step 1. When I press the next push button, we should move up to step 2, and this should open here. Okay, nice. So now we're in step 2. Then if we move up, then when I hit the push button once again, step 2 will be completed. Step 3 will then be true. A little bit of a lag here. It's almost as if it went through all the steps, right? It was weird. So step 3 just came in. And finally for the next one, once I press the push button, it goes to step 4. Okay, so step 4 is now true. And then if we look above, then by pressing the push button one more time, then we move to step 5. Beautiful. Step 5, you couldn't see because it just hit step 5 and brought us right back to step 1. So if I cycle down here, you'll see that step 1 is now true. Excellent. Okay, so now you've seen the program working. Let me show you how to build up this program. And we'll start off with the tags first. So we'll start off with these guys. So give me 2 seconds. Let me go offline, get back to my PLC tags, and we'll start off with those guys. Okay, walking through the tag table now. Each of our steps are going to come here. So we're going to have 5 different steps. And so each one is going to be a separate memory bit. So step 1 is M0.0. Step 2 is M0.1. 3 is M0.2, 4 is M0.3, and step 5 is M0.4. We have two lights that we're going to turn on. So light 1 is going to be Q0.0, light 2 is going to be Q0.1. Okay, the push button is going to be a memory bit. That way we can toggle it within the PLC sim table. So that's going to be M0.5 following here. And then I'm going to make use of, because I'm going to make use of the positive edge in each of the different steps, I'm going to have separate positive edge memory bits for the push button. So we have step 1, step 2, step 3, step 4, and step 5. Okay, once you've done that, then let's go back to our main OB. And you'll see here that I've started off with my step 1, step 2, step 3, and step 4 outputs. So all I've done is taken those memory bits for step 1, and that guy is going to set the light, right? So we said that our first step was that the first light was going to turn on, so we'll do that here. Okay, second step, obviously by M0.1, is going to be that the second light is set or turned on. Third step, M0.2, resets our first light, so turns that first light off. And then finally, step 4 resets the second light. Okay, there's nothing for step 5 because remember, step 5 is just going right back up to step 1. Okay, so there are other ways to do this rather than just doing kind of this linear programming all in one shot here with no subroutines or anything like that. But we'll get to that later on when we get to the assembler and stuff. So building up to that, we're seeing how to create a sequential program. So starting off, we have our outputs here. Those are networks 1 through 4. And if we scroll down here now and take a look at our other networks, it's a weird way to do this. So I actually have step 5 first, then step 4, then step 3s, then step 2, then step 1. Right, so we have these guys in descending order. Normally we would do step 1 in network 5, right? And then step 2 in network 6, step 3 would be here, and then step 4 and step 5. The way that I've done this is I've done it in descending order so that step 1 is actually the lowest portion of my program. So remember that for the scan cycle, it goes from the top all the way to the bottom, right? And then recycles to the top there. So trying to stop sequences from coming in or steps from coming in, 1, 2, 3, 4, 5 in a quick manner, I want to be able to step 1, 2, 3, 4, 5 every time that I hit that push button. So one of the ways to aid that is to put your steps in descending order. Okay, well, at the end of the video, we'll come back to this and we'll see in ascending order whether it actually makes a difference. But sometimes it will make a difference in that obviously step 5 can't happen until step 4 happens, and step 4 is below. Step 4 can't happen until step 3 happens, and step 3 is below. So hopefully this will help us to get nice clean steps here. Okay, so what you're going to do then, for each step, we're going to start off here with our step 1. Okay, once this is done, like once this network is done in network 5, then we're going to click on here, we're going to insert a network, and then we're going to start on the next network above. So in between networks 4, and this will end up being network 6. Okay, so I'm going to start off with this guy being just a push button. Okay, so each of these guys are just going to be a push button for now. I'm going to highlighting something first, right? So showing you how it's not going to work, and then we'll go back to these positive edges here. Okay, so everything is now just a standard push button. Okay, and in the first step, so this is my step 1 definition, I'm saying that, okay, I'm going to hit the push button, and step 3 has not happened yet, step 4 has not happened, step 5 has not happened, and then step 2 has not happened. Now, why do I have step 2 over here rather than in line here, right? Wouldn't it make sense to go 2, 3, 4, 5? It may, but as soon as step 2 happens, then I want to be able to stop step 1. Okay, so when this is true, this will no longer be true, and that means that step 1 will be a 0. Okay, so as soon as the next step happens, it will, in this case, be untrue here and stop the previous step. Okay, we have that on everything, right? So here you can see that that as soon as step 3 happens, then it turns off step 2. As soon as step 4 happens, it turns off step 3. And above, as soon as step 5 happens, it turns off step 4. Okay? You'll see that for step 5, there's nothing like that because it doesn't have a holding contact. So every one of our steps here has a holding contact across the initiating or definition of that step there. So going back to here, hit the push button, and step 2, 3, 4, or 5 have not happened yet. So step 1 is true. Okay, once step 1 is true, then obviously this holding contact is true, and it bypasses everything that defined step 1, except for the next step. Okay, in addition to that, I've also got step 5 in parallel, and that's because remember that step 5 brings me back to step 1. So I've got this next instruction here in parallel. So hopefully everything makes sense for step number 1. And again, as we were building this up, that network would be right here in network 5, right? So we want to put each subsequent step above that. So we're clicking here once we did that step 1, right? Then we're going to insert a network, and then we'll place the next network in there and then drop it in above that the previous network. So every time that we create a new network, we bring it above the previous network, and then everything will be in descending order. Okay, so hopefully everything makes sense in step 1. Okay, then we created another network. We brought it above our step 1. So this is our step 2. And then we start doing the logic for step 2. Now you'll see that the logic here, here, and here is identical. Okay, so step 2 definition is that again we hit the push button. Step 1 has been confirmed, right? So we've already done step 1, but step 3 has not happened yet. So that makes step 2 true. When step 2 is true, we have a holding contact here that goes across the defining contacts for step 2, but not across this instruction right here. Remember that once step 3 happens, this will no longer true, and that will kick out step 2. Okay, once step 2 happens, then that means that this is true above. Okay, again, we're inserting a network, right? Bringing it above and putting step 3 above step 2. And in this case, exact same logic. Hit the push button. Step 2 has been confirmed to being true. And then step 4 has not happened yet. In that case, turn on step 3. When step 3 is true, holding contact bypasses the definition of that step, except for this instruction, which is for the next step here. As soon as step 4 is true, this is no longer true, which breaks this logic continuity for step number 3. Okay, step number 3 was true, which means this guy was true, right? So it means that if we've next put the push button and step 3 has happened and step 5 has not happened yet, then turn on step number 4. Again, holding contact across the initiating contacts here. And as soon as step 5 happens, then it will make this untrue, which will block the logic continuity, and step 4 will then become a 0. Okay, finally for step number 5, hitting the push button once again, step 4 has been confirmed, and then go straight to step 5. There's no holding contact right here, so that as soon as the push button is released, then step 5 is no longer true. But as soon as step 5 was true, then we have this holding contact down here, which then sends a signal to step number 1. And as long as step number 2 is a 0, which it is because we kicked it out when step 3 happened, then step 1 can be true again, and the whole cycle can start again. Okay, so I've made this change to the program by placing in just single push buttons here. Okay, so let's download that change, and we'll see how that affects our program here. Okay, so because I already had PLC Sim up and running, step 1 is already coming through. So let me see if I can modify that. Remember, to modify the memory bits, I need to have this enable disable modification of non-inputs. So let's do this. Okay, beauty. So step 1 is no longer true. So now it's waiting on the push button here. So watch what happens when I hit the push button and I don't have just the positive edge on here. So ready? 1, 2, 3, hitting the push button now. Okay, so step 1 came in. Okay, moving on to step 2. And what happened there? So I went right back to step 1. You see that flash there? And then we're right back to step 1. Let's try that again. Hitting the push button again. Okay, and right back to step 1. So it seems like it goes 1, 2, 3, 4, 5, and then right back to step 1. All right, if we scroll up here, you can see that right now we're randomly on step number 4, right? So it depends on where I let go of the push button. I'll press it again. Okay, and I'm now back to step 1, pressing it again, and I'm back to step 4. So I seem to be randomly going to either step 1 or step 4 when I hit this push button. So the reason for that is because remember on the timers and stuff, when you hit this push button, then the scan cycle is happening so fast that I may be hitting this push button for like a millisecond or two, but in that millisecond or two, the program can go 1, 2, 3, 4, 5, right? Even though I put it in descending order here, 5, 4, 3, 2, 1 with my steps, every time I hit this push button, I'm actually sending a number of signals through on that push button, and so it's just flying through, and now I'm on step number 3, and I was on step number 4, right? So every time that I hit this push button, I just randomly go to a different step. Now I'm on step number 2. Okay, so let's go offline now. And let's go back to making use of the positive edges now. So now you can see that doing a sequential program is quite hard, right? So every one of these guys is now going to become the positive edge. So once it goes from a 0 to a 1, that's the only time that we want that signal coming through. We only want a pulse coming through for each of the presses of the push button. That way, hopefully, only one scan cycle will be true for this push button for each step. Okay, for each of these guys, that's going to make use of a memory bit in order to compare the previous state to the state that it is in now. So these are our positive edges for 1 and for 2 and for 3 and for 4. Again, there are other ways to do sequences here. I'm just showing you this particular way to do a sequence. Not necessarily the best way, but it shows you how frustrating this can actually be. Okay, we made some software changes, so let's download that to our PLC. Beauty. Okay, so we're back up and running, and I'll bring up our PLC sim now. So now I'm clicking on the push button here. At the moment it's false. Step 1 has not come in. Step 2 is stuck here though. So let's get rid of step 2. Okay, light 1 and light 2 are on, so we need those guys off. So everything's false at the moment. Looks good. So going back to the push button. Now when I press the push button, this positive edge will only come through, hopefully for one scan cycle, and just keep us in the first step here. So doing that now. Oh, nice. Okay, so step 1 is true. Okay, holding contact, keeping that guy on. Okay, because you'll see that here, this is no longer true. Okay, then we're moving up to this one right here. I will press the push button. This is true. Step 1 has been confirmed. Step 3 has not happened. So next time I hit the push button, that positive edge will come through for one scan cycle and bring me to step number 2. And we can see here that step 2 now is true. Beautiful. Okay, and we haven't gone ahead, right? So step 1 is true, so that means that the second light is on now. Okay, if we move up here, then we'll look at step number 3. So hitting the push button again. So step 2 is true. Step 4 hasn't happened yet. We're waiting on this positive edge. Hitting the push button. Step 3 comes in. Beautiful. Scrolling up. Okay, let's press the push button again because step 3 is true. Step 5 hasn't happened. Waiting on the push button positive edge again. Right now we have the first light off. Now when we hit the push button, the second light should turn off. Beautiful. Step 4 has now been completed. Excellent. And if we move up to here, and step 5, again, when we hit the push button, then this positive pulse will happen for one scan cycle. Step 5 will be true, and then we should find that the holding contact down below closes. So I'm actually going to scroll down to the holding contact here because we know what's going to happen. We're not going to be able to see anything on network number 5 right here. So let's go down to network 9. and we'll finally see that this one comes true and turns on step number 1 once again. Okay, hitting the push button one more time. Beautiful. Step 5 comes through. That was like so brief, right? So step 5 came through, and then step 1 is now true, and the first light is on. All right, guys, so here we've got a pretty cool program where we can hit the push button, and every time that we hit the push button and we get that positive pulse, we get that clear step change from 1 to 2 to 3 to 4, and then finally 5 brings us back to step number 1. Beautiful. All right, guys, before I finish off this video, what I'm going to do is I'm going to put these in ascending order and see if that changes the sequence of events whatsoever. Because right now we have obviously step 5, 4, 3, 2, and 1 in descending order. So I'm going to put them in ascending order and see if that changes the logic at all. Okay, guys, so now we got every step in ascending order, and we'll see whether that changes the step sequence here. So hitting the push button now to send me into step number 1. My step 1 is not coming in. Isn't that crazy? You would think that putting in an ascending order that everything would be perfectly fine, right? So right now it looks like we have logic continuity right across here, right? But when I bring up my PLC sim again and I hit that push button, then nothing's coming in whatsoever. So I find sequential programming to be super frustrating, right? In that this should work. It should be that step 1 happens, and then step 2, step 3, step 4, and step 5. So is it the fact that everything's happening too fast? You would think that it would revert back to step number 1 at least, right? Because before we saw it went right back to step number 1, but nothing seems to be coming in whatsoever. So it's interesting. I thought it would actually, you would see the sequence of steps happening there, like really fast, because we're doing an ascending order, but nothing's working at all there. Interesting. Okay, so let's go back to the descending order and we'll see whether the program works. So try it out, guys. All I did was I took my networks and just, I went offline, and I literally just grabbed the network and dragged it above there. Right, so there's step 2 above, then I need to bring step 3 in to the top here. So step 3 above step 1, then step 3 above step 2. And again for step 4, just bringing that guy up. Okay, finally, and then step 5 is going to bring to the top there. So we'll be in descending order. Okay, step 5, step 4, step 3, step 2, step 1. Okay, let's download that and see if it works, or whether I messed up my program somehow. Okay, descending order now. We're looking at step 1 here. So I'm going to hit the push button now. Look at that. Exact same sequence, right? Step 1 through 5, by putting it in descending order now. Step 5 cannot happen until step 1 happens. Step 4 cannot happen until step 3, step 2 until step 1. So it looks like everything's back to normal and everything is working. So keep this in mind for sequential programming, that it seems counterintuitive, but you may want to do your steps in descending order. In this case, 5, 4, 3, 2, and 1 for them to come in properly. All right, guys, hopefully you enjoyed this video. This was a crucial step for me to understand the limitations of this type of programming, and not using subroutines or anything like that, not using counters to keep track of the steps, not using move instructions to keep track of the steps, and just using linear sequential programming. So try it out both in ascending and descending order, and see whether you get the same results. All right, guys, I'm going to see you in the next video.